Download this code from codegive.com, link in the description below. OK, let's dive deep into function composition and domain, covering the core concepts, potential pitfalls, and practical examples. What is function composition? Function composition is the process of applying one function to the result of another function. Imagine you have two functions, f, x, and g, x. The composition f, g, x, often written as fg, x, means that you first apply the function g, x, to the input x, and then you apply the function f, x, to the result of g, x. It's like a chain reaction. Notation asterisk. Asterisk f, g, x, is the most common and clearest notation. Asterisk, fg, x, is the formal notation, read as f composed with g of x. Analogy asterisk. Think of a factory assembly line. One station might prepare a part, and the next station paints it. The overall process of preparing and painting is a composition of the preparation function and the painting function. Important considerations asterisk. Asterisk order matters asterisk f, g, x, is generally not the same as g, f, x. Composition is not commutative, like multiplication or addition. Asterisk inner first asterisk you always evaluate the inner function first. In f, g, x, g, x, is evaluated before f, x. Asterisk output as input asterisk the output of the inner function becomes the input for the outer function. This is where the concept of the domain becomes crucial. Domain of a composite function. The domain of a composite function f, g, x, is the set of all x values that satisfy both of these conditions. One x must be in the domain of the inner function, g, x. This means g, x, must be defined, not produce an undefined result like division by 0 or taking the square root of a negative number. 2. The result of g, x, must be in the domain of the outer function, f, x. This means f, g, x, must be defined. In simpler terms, you can't put anything into the machine, inner function, that will break it, and the output from that machine must be something the next machine, outer function, can handle. Why is the domain important? Ignoring the domain of a composite function can lead to incorrect results or misleading conclusions. You might calculate a value for f, g, x, for a particular x, but that value is invalid because x isn't actually in the domain of the composite function. Steps to determine the domain of f, g, x. 1. Find the domain of the inner function, g, x, identify any restrictions, division by 0, square roots of negative numbers, logarithms of non-positive numbers, etc. 2. Find the domain of the outer function, f, x, identify any restrictions. 3. Consider the range of the inner function, g, x, with regards to the outer function f, x, s domain determine for which x values, the result of g, x, would violate the domain of f, x. 4. Combine the restrictions. The domain of f, g, x, is the intersection of the domain of g, x, and the set of all x values for which g, x, is in the domain of f, x. Code examples, Python. Python doesn't have a built-in function for function composition, but it's easy to implement. Let's create some example functions and demonstrate how to compose them and determine their domains. Explanation of the code asterisk. 1. Function definitions asterisk. We define several simple functions, f, g, h, j, k, l, with different domain restrictions. 2. Compose, f, g, x, Function asterisk. This function implements the composition. It first evaluates the inner function g, x, then it evaluates the outer function f, gx, only if gx is valid, not none. If any function returns none, it signals a domain violation and the compose function also returns none. 3. Domain checks asterisk. The code demonstrates how to check for domain violations. Asterisk. In f, g, x, we note that g, x, has no domain restrictions, but f, x, requires x equals 0. Therefore, we need g, x, equals 0, which means x, 5 equals 0, so x equals 5. Asterisk. In h, j, x, j, x, has no domain restrictions, but h, x, requires x, equals 0. Therefore, we need j, x, equals 0, which means x caret 2, 4, equals 0, so x, equals 2 and x, equals dash 2. Asterisk. In k, l, x, l, x, has no domain restrictions, but k, x, requires x 0. Therefore we need l, x, 0, which means x plus 3 0, so x dash 3. For none. For undefined asterisk. The functions return none if their input violates their domain. This is a simple way to signal that the function is undefined for that input. A more robust approach might use exceptions, but none is sufficient for this example. More complex examples. Let's look at some more complex examples where finding the domain requires a little more algebra. Example 1 asterisk. Asterisk f, x, equals 1 slash, x, 2. Asterisk g, x, equals sqrt, x. We want to find the domain of f, g, x, equals 1 slash, sqrt, x, 2. 1 domain of g, x, asterisk x equals 0. 2 domain of f, x, asterisk x, equals 2. 3 restriction on g, x, due to f, x, asterisk we need g, x, equals 2, which means sqrt, x, equals 2. Squaring both sides, x, equals 4. Therefore, the domain of f, g, x, is x equals 0 and x, equals 4. In interval notation, 0, 4, u, 4, infinity. Example 2 asterisk. Asterisk f, x, equals sqrt, 4, x. Asterisk g, x, equals x caret 2. We want to find the domain of f, g, x, equals sqrt, 4, x caret 2. 1 domain of g, x, asterisk all real numbers. 2 domain of f, x, asterisk 4, x equals 0, which means x equals 4. 3 restriction on g, x, due to f, x, asterisk we need 4, g, x, equals 0, which means 4, x caret 2 equals 0. This is the same as x caret 2 equals 4. Taking the square root of both sides, dash 2 equals x equals 2. Therefore, the domain of f, g, x, is dash 2 equals x equals 2. In interval notation, dash 2, 2. Important considerations for domain analysis. Asterisk even roots asterisk expressions inside even roots, square root, fourth root, etc., must be greater than or equal to 0. Asterisk rational functions asterisk denominators of rational functions, fractions, cannot be 0. Asterisk logarithms asterisk the argument of a logarithm must be strictly positive. Asterisk trigonometric functions asterisk be aware of restrictions on trigonometric functions, Example 10, x is undefined at x equals pi/2 plus k asterisk pi, where k is an integer. Asterisk piecewise functions asterisk if f, x, or g, x, are piecewise functions, you need to analyze the composition separately for each piece. Practical applications. Function composition is a fundamental concept in mathematics and computer science. Here are a few examples. Asterisk calculus asterisk the chain rule for differentiation is based on function composition. Asterisk computer graphics asterisk transformations in computer graphics, rotation, scaling, translation, are often implemented using matrix multiplication, which is a form of function composition. Asterisk signal processing asterisk applying a filter to a signal can be thought of as a composition of the signal function and the filter function. Asterisk programming asterisk many programming patterns, example decorator pattern, rely on function composition. Functional programming languages often provide built-in features for composing functions. In summary, asterisk function composition is a powerful tool for combining functions and creating more complex behaviors. Understanding the domains of composite functions is essential for ensuring that the results are valid and meaningful. Take your time to work through examples and practice, and you'll master this important concept.